Hello, my name is Naseem. In last video, we tried to implement the histogram of the data set which we have. We implemented it successfully. What we got is that the histogram is actually a childish form of the Gaussian distribution, or you can say binomial distribution. But every time when we are getting some historical data of a process in real time, when we are using this historical data as a training data set to implement some machine learning algorithms, we must do some analysis of the data sets, right? So we must check whether the data points inside the data set are normally distributed or not. I mean Gaussian distributed or not. We are having a number of methods to do it, and I actually divide this method into two different category. One is visual checks, where we just take the data, try to plot some graphs of the data set, and by visually we just analyze the data and we decide whether this data set is normally distributed or not. So these are visual checks. We have another checks which is statistical checks, and these statistical checks, we have a number of algorithms where we can feed this data to those algorithms, and these algorithms will calculate some parameters. On the basis of the values of the parameters, we will decide whether this data which we are having is normally distributed or not. So we have a number of different statisticals Gaussian check method. We have Shapiro-Wilk test, we have skew and kurtosis test, and as a third we have Anderson-Darling test, right? So one by one we will try to implement these tests differently in this video, and we will try to understand how we can verify whether the data we are getting is a normal distributed or not, right? So I will start with the visual check first. In visual check we have two different type of checks. One is histogram. We just draw histogram of the data points which we are having, and by seeing this histogram we decide whether this data set is normally distributed or not. If we are getting histogram of the data set in a bell curve, we just decide yes, this is a normal distributed data set. We have already done this in our last video, and you can see in my current screen as well. We have draw a histogram of the temperature column of a data set, and this is the data set we have. By using this data set, we have created the data histogram of this column, which is D, temperature C, and what we find out is that the histogram of the data is somewhat bell curve, and this is why we just say yes, this is a normal distribution. Second method of visual check is quintile plot, and in this quintile plot we need to feed this data to a specific algorithm, and this algorithm will take data. It will divide this data into groups of 5 different points, or it depends on us. If you wanted to divide these data points into a group of 5 or 10 or whatever custom, it depends on you. But we will try to draw this quintile plot by grouping these data points into 5 data points. What this algorithm quintile plot will do, it will take data from us, and at the same time it will create some data set, and these created data set by the quintile algorithm will be perfectly normal, and then it will try to these two data points together, and it will draw these data points into a x-axis and y-axis. Let's try to use the same data, means temperature column data set, and try to implement this quintile plot for us. So what we need to do, this line of codes are creating histogram for us, and if we wanted to try quintile plots, then we need to work with the SciPy module of the data analysis. And SciPy is the widely used data analysis library in Python, which we will use to analyze the data, to make correction in the data, and for different purposes, right? So we will use a specific method of the SciPy library. So let's start. We are creating Q to Q plot, and how to create. So first thing we need to do is to import SciPy. So import SciPy, and from SciPy we need to import stats. Just create this stats class as stats, and we can plot quintiles, right? So how we can do it? Stats, we have stats dot, we have a method which is probab plot, and in this probab plot we need to pass data for which we wanted to create this diagram. So we have data which is temperature data, just pass it here. We need to pass some more parameter of this function. So we have first parameter which is dist, and into this parameter we need to pass norm, right? Because we are creating normal diagram, normally distributed quintiles, because I already explained that this quantile plot will create its data at the same time, and it will try to plot these data points onto a x and y axis, and by seeing this plot we can decide whether our data set is a normal or not. So because we are checking for the normally distributed, we need to pass this value norm. We need to plot by using PLT. PLT is the instance of the pyplot class we have already defined, and just go and write plt.show. That's it. If we select it and run this, this is what we are getting. So this is the first, means histogram, and this is the pyplot we are getting. So this is the pyplot we are getting. According to this quantile and quantile plot, what we are having, that somewhat our data points are not matching perfectly with the normally distributed line, which is red line we can see, right? Our data set is not perfectly matched with the line of the quantile plot. So by seeing this plot, we can decide whether this data is normally distributed or not. It looks normal to me because in practical, no data would be 100% normal. It is our assumption that every process which is creating a data set for us, a historical data set for us, is a normally distributed process. And because this process itself is a normally distributed, so the data which this process is creating will also be normally distributed. But it is not 100% true, means every data is not 100% normally distributed data. And this is what this plot, this quantile and quantile plot, is showing us, that the data is not perfectly matched here, and this data is not perfectly matched here as well. So this is what about histogram and the quantile plot. We will quickly jump into the next methods to find out whether our data set is a normally distributed or not. I mean statistical Gaussian check. So the first method we will try is Shapiro-Wilk test, because this time this Shapiro-Wilk test are having some algorithm in the backend, and we need to pass the data only to those algorithms, and these algorithm will calculate some parameter for us, and this parameter, on the value of this parameter, will tell us whether our data set is a normally distributed or not. So we need to supply our data set to this specific algorithm, which is Shapiro-Wilk algorithm, and this Shapiro-Wilk algorithm will calculate some parameters value, and on the basis of the values of these calculated parameters, we will decide whether our data set is normal or not. All right, so we need to make first some hypothesis about the data. So what we assume is that we have a data set created by a normally distributed process. This is our assumption, means the process which is creating this data set is a normally distributed. To verify this assumption, we need to make some hypothesis. And what is this hypothesis? We need to feed this data to Shapiro-Wilk algorithm, and this Shapiro-Wilk algorithm will calculate some p-value for us, and we need to make whether this p-value is greater than 5%, right? Means this p-value is greater than 0.05. If it is greater than 0.05, we can say that the data which we are having is a normally distributed data. And if p-value of this data set is less than 0.05, then the data is not normally distributed. So let's start. Again, we need to use SciPy. So from SciPy dot stats Shapiro, right? We have Shapiro, and by using this Shapiro, we need to find out two different parameters. So let's call it para1 and the p-value. And how we can calculate parameter value? Let's call it statistical parameter. So stat para, and we have p-value. And how we can calculate it? Shapiro, the same class which we have imported, Shapiro, and we can feed the data set which we have. So we are talking about the data set, means temperature data set of this Excel file, of this CSV file. Just pass it, and we will be getting these two values for us. So we have defined a specific value, means if the p-value, means the p-value of the Shapiro-Wilk algorithm is greater than 0.05, then the data set is Gaussian data set. So if, let's try to implement the same functionality, p-value, try to implement this functionality, try to run the whole code. Again, we are getting histogram, quantile plot, and we are getting that data is not normal. All right, if you wanted to know what is the p-value, then we can print the p-value as well. Print, let's call it p-value of Shapiro-Wilk test equals to, just add it, and we can call p-value. No error. Let's run this code. Can only concatenate string, not float. because p-value is a float type of value, and we are concatenating, we are trying to add a string with the float, which is not possible. So somehow we need to convert this p-value into a string, and how to convert some another value to the string in Python is by str and pass this p-value. That's it, and run this once again. So this is what we are getting. Again, histogram, quintile plot. We are having p-value of Shapiro-Wilk test, which is 0 0. So 0 0 is less than 0.05. Condition got wrong, and we are getting data is not normal. This is how we can use Shapiro-Wilk test to verify whether our data set is not normal or is normal or not normal, right? In the same way, we have different tests like skew kurtosis test, and third one is the Anderson and Darling test. I have provide link in the description of this video. You can download the file and you can run these tests by yourself onto the data set, and you can verify whether your data is a normal distributed data or not. What we are finding out that the data which we are having is not normal, right? So how we can make our data set normal in this case? What are the steps need to be taken to make our data set more normal, right? To pass some test, whether Anderson-Darling test or Shapiro-Wilk test or skew and kurtosis test. So in next video, we will try to understand a number of different methods by which we can use and we can make our data set more normal, and we can use this data set for machine learning implementation. I hope you enjoy this video. Happy learning, and see you in next video.